Hello, hello, hello. Today we're going to be covering exponential functions, which is a really, really easy chapter. And with exponential functions, we have a standard form. It's not a standard form. It's a form that you could just memorize, which is the following. F of x equals to a times b to the power of x. Similar to linear functions, let's say f of x equals to mx plus b. This equation looks familiar, right? And we're done with that. We're done with linear equations. We're growing up. We're adults now. We move on to exponential functions, which is the following. F of x equals to a times b to the power of x. Now, a is simply your initial value. So a is the initial value. And what does b represent? B is called the word base. So b is short for base. Now, x is simply the power of b, and that's it. It's that simple. Exponential growth means that the function is simply increasing, as you can tell. Exponential decay is simply a decreasing function. Now, since we graphed this, let's understand what's going on. So you must first understand that b, let me open a whiteboard. Okay, here we go. You must first understand that the value of b can be greater than 1, or it can simply be between 0 and 1. But please, please, please understand or memorize that b can never be negative. Okay? So b would either be greater than 1 or between 0 and 1. We're good? Now, let's have a look. Why am I telling you this? Because if it's greater than 1, you're going to get a graph. And if it's between 0 and 1, you're getting another graph. Let's have a look at the graphed function, the graphed exponential functions. Let's have a look at the first one. Now, this is simply f of x, which equals to, let's say, 2 multiplied by 3 to the power of x. Now, this is the classic one, right? Now, why is this true? Well, you test some values. Let's say you're approaching from the left side, right? Coming from the left side, x equals to negative infinity. So you could do 2 times 3 to the power of negative 1 million, let's say. Plug this in your calculator, you're simply going to get 0. As we move on to the right side, I want you to plug in 1 million for x. What are you left with? Well, it's going to be infinity, right? So that simply tells you that coming from the left side, f of x is 0, and what else do we get? We get infinity, okay? What about the function below the x-axis? Well, this is simply f of x, which equals to, do you want to give a guess? Well, if I have a point over here, which is, let's say, 1, 1, I want to go down here, this point would still have the same x value, but what happens to the y value? It's negative 1, right? So I'm just changing the y value, and to change the y value, remember x is simply x, and f of x represents y. So to change the y value, I'm just doing negative f of x, right? Which is simply equal to negative 2 times 3 to the power of x. So the bottom function is just negative times 3 to the power of x. I do suggest you test it out. Plug in negative 1 million to x. Coming from the left side, you're going to get 0. And then plug in 1 million to the right side, you're going to get simply negative infinity. Now, what else do we have? Well, let's say we have a function that is simply coming from infinity and approaching 0, then a function coming from negative infinity and it's also approaching 0. Okay, well, let's start with the first one. F of x equals to, let's go with the same exact function, 2, but in this case, the first one, b was greater than 1, which is 3. Now it's between 0 and 1, it's raised to the power of x. Now, if you want to simplify this, isn't this simply 2 times 3 to the power of negative 1 to the power of x? Remember, if I want to find the reciprocal of 1/3, I would just switch the numerator and the denominator. Now I have a negative, so this is simply 2 times 3 to the power of negative x. Coming from the left side, isn't this simply 2 times 3 to the power of negative 1 million? Well, look, you could have just plugged in 1 million, negative 1 million for x, and you would have got infinity. So this is 3 times a million, which is simply just equal to infinity, right? So coming from the left side, we're coming from infinity. And moving on to the right side, as you plug in negative infinity for x, you're simply going to be left with 0. Now, what about the bottom function? Well, it's just negative f of x, which is just negative 2 times 1/3 of x. Plug in negative infinity, which is approximately, it's not approximately, but like plug in negative 1 million into x, you're going to reach a really huge negative number that has a really large magnitude, which means that it's negative infinity. If you plug in 1 million into x, you're going to reach a number really close to 0, which means we're approaching 0. Now, those are the only 4 graphs of exponential function that you need to memorize. And that's it. That's basically it for the graphing part. Now we can move on to solving actual questions, which is very simple as well. Don't worry. Have we done this before? Maybe yes, maybe no. I genuinely don't remember. Okay, anyways, moving on. Okay, just to give you a quick recap on linear functions. So g of x is a linear function, 2 of x, f of x is an exponential function. You can watch the behavior, it's quite different. But what's so cool about exponential functions is that they're proportional. So if I divide 8 by 4, isn't that simply equal to 2? Isn't that equal to 4 divided by 2, which equals to 2 divided by 1, which equals to 2? That's what's so cool about exponential functions, is that they're proportional. Now, what else do we have? So yeah, I told the exponential growth refers to the original value from the range increases by the same percentage over equal increments found in the domain. And linear growth is basically increased by the same amount over equal increments. Now, with exponential decay, we're basically decreasing as a percent. So let's say 1 minus 10%. Isn't this equal to 0.9? And isn't 0.9 simply a value between 0 and 1? So that's decreasing basically. Let's say I'm adding 10%. This refers to adding a value. So it's 1.1 if I'm not mistaken, which is a value greater than 1. And that's basically exponential growth, given that a is positive though. Anyways, moving on to b, which is greater than 1. It grows at a rate proportional to its size. B is between 0 and 1, simply decays. And reminding you that a is positive. They're mentioning that a is any non-zero number. But the thing is, if it's a negative number, then this wouldn't be the case. So that's why I explained it through graphing it at first. Understand the graphs, and that's what it's important. If you understand the graph, I'm pretty sure you're going to be able to tackle any problem. Moving on. Let's define the behavior of the graph of the exponential function and highlight some of its key characteristics. We have the domain, which is from negative infinity to infinity. The range is from 0 to infinity. Remember, range represents y, domain represents x, this represents x, and range represents y. As x approaches infinity, f of x approaches infinity, which is true. As x approaches infinity, y approaches infinity, which is correct. Okay. Now, f is always increasing. The graph of f of x will never touch the x-axis because base 2 raised to any exponent never has the result of 0. And this will never touch. That's correct. It's approaching but it never touches. And y equal to 0 is the horizontal asymptote. And the y-intercept is simply 1, and that is it. Okay. Moving on to the exponential function, which we just took. We're good on this. We can keep on moving down to, let me see. Okay. A function that models the exponential growth grows by a rate proportional to the amount present. And yeah, we mentioned that A is the initial value, B is the growth factor or growth multiplier per unit x, if it has a growth factor. Okay, now this is the important part. Now, let's say, we're going to do an example because they didn't offer us one. Let's say you're given g of x, which equals to a times b to the power of x. And I tell you, hey, this function is passing through 0, 5, and it's also passing through 10, whatever, 15. Find the exponential function. Well, the first step is to plug in this point. You have g of 0, which equals to a times b to the power of 0, where g of 0 equals to 5, which equals to a times b to the power of 0. A simply equals to 5, and that's it. Why? Because b of 0 equals to 1. Anything raised to the power of 0 gives you 1. Now, if a equals to 5, now we can use the second point, where g of 10 equals to a times b to the power of 10. Now, what do I have? I simply have g of 10, which equals to 15, which equals to a, which is 5, times b to the power of 10. B to the power of 10 equals to, actually, okay, let's change this to just b to the power of 1. Just for the sake of making it convenient. Okay, there we go. So this is 1. So 15 divided by 5, which equals to 3. Okay, so b equals to 3, a equals to 5, which simply means that g of x equals to 5 times 3 to the power of x, and that is your exponential function. And this is if you're given that x equals to 0. If you're given a point where x equals to 0, you start with that point, you find a, and then you can simply find b by plugging the second point. But what if the 2 points given do not include, well, x equals to 0 is basically the y-intercept, right? What if the 2 points given doesn't include, what if the 2 points given don't include the y-intercept? Well, let's have a look. Let's say we have, let's go with an easy number. I don't know, let's go with 2, maybe? Anyways, so if you're given these 2 points, how do you solve it? Well, you just plug in. So we're going to start by, actually, let's make this 45. Let's turn this into 4. Would that help us? I have no clue. Anyways, would it? Let me think of good numbers. Okay, well, the 5 is kind of ugly, so let's erase that. Let's turn this into 16. Let's turn this into 2. Let's turn this into 4. Okay. So if I have... First, you need to plug in both points. G of 2 equals to A times B to the power of 4, right? And then I have... Wait, what on earth did I just write? I'm sorry about... Okay, G of 4 equals to A times B to the power of 4. And I have G of 1, which equals to A times B to the power of 1, right? Now, what is G of 4 equal to? Well, G of 4 is just 2, right? Which equals to A times B to the power of 4. And I have 16 for G of 1, which equals to A times B to the power of 1. How do I find the value of B? Well, why don't I just divide the second equation by the first? Equation number 2 and equation number 1. If I do equation number 2 divided by equation number 1, wouldn't that help me cancel out the A? Why? Okay, let's change this. Let's turn this into 1. Let's turn this into 4. Okay, now I'm writing right to left. There you go. Okay, let's erase this. Now we have some good numbers. So let's assume it was G of 1. There you go. G of 1, G of 4, and this is 4. Why am I doing this? So you have a good understanding when it comes to simplifying. Now, dividing the second equation by the first, AB4, we could have just went with the first set of numbers, but that's not going to give you a good understanding of how to simplify. I mean, it could have been possible, but I just don't want you to find this complicated at first. Okay, anyways, AB4 divided by AB1. A and A cancel out. What are we left with? We're left with B to the power of 4 minus 1, which is just B to the power of 3. Now, if I divide 16 by 2, because remember, this is also equal to 16 divided by 2. Isn't this equal to 8, right? 16 divided by 2. So B equals to 2. Now, how do I solve this? You can take any equation. Let's take the first one, where G of 1 is just 2, which equals to A times B to the power of 1, right? Remember, B equals to 2, so it's just 2 to the power of 1. Now A equals to 1. So what is the final equation? G of x equals to 1 multiplied by 2 to the power of x. So G of x equals to 2 to the power of x, and that's your exponential function. What I want from you is to try and solve example number 5. You're given 2 points. I wish you the best of luck. And try and find the equation for the exponential function graphed here. Well, I'm going to give you a hint. You have 1 point, which is 0, 3. And you have this point, which is 1, 6. I wish you the best of luck as well. We will see you tomorrow. Thank you. Bye-bye.